It starts perhaps with a dull throb, just behind your eyes maybe, or perhaps it's a twinge in your back, a stiffness in your neck after a long day, that unwelcome visitor we all know, pain. It's a universal language, isn't it? One we'd all rather not speak so fluently. But there it is, barging in uninvited. Consider the humble headache. It doesn't care if you're a queen or a refuse collector. Suddenly, your grand plans for the day? They shrink a bit, replaced by a fervent wish for quiet. So, what is this thing called pain? It's not just a feeling, you see. It's a complex process, a very sophisticated alarm system in fact. Your body's way of shouting, "Oi, something's not right here." When you damage a bit of yourself, say, by stepping on a rogue piece of Lego, the injured cells release a cocktail of chemicals, things with wonderfully dramatic names like prostaglandins. These chemicals are like tiny town criers, rushing about, shouting about the injury. They make the local nerve endings extra sensitive. These sensitized nerve endings are your pain receptors, nociceptors if you want to be fancy. When they detect those alarm chemicals, they fire off a message, an electrical signal, zipping along your nerves. Right, so you've got this pain signal. It's like an express train heading for your brain. You swallow a painkiller, what happens next? It's not teleported directly to your sore knee, sadly. That would be terribly convenient, but no. First, it has to undertake a bit of a journey. Down the hatch it goes, into your stomach. From the stomach, the pill begins to dissolve. Or if it's a capsule, its casing breaks down, releasing its active ingredient. This is the business end of the painkiller. It then gets absorbed, mostly in your small intestine, passing through the intestinal wall, and into your bloodstream. Once in the bloodstream, it's like joining a motorway. The painkiller molecules are whisked all around your body, to your liver, your lungs, your big toe, your earlobe. Everywhere the blood goes, basically. Let's talk about paracetamol. Known as acetaminophen in some corners of the globe, it's probably the most common painkiller in the medicine cabinet. The go-to for headaches, mild fevers, and general achiness. It's often seen as a gentle option, and for many, it is. But how it actually works is still a bit of a mystery. Yes, even now. Scientists are still scratching their heads a bit. We know it's good at reducing fever, and it certainly helps with pain, but it doesn't seem to have much effect on inflammation, unlike ibuprofen or aspirin, which are all about calming redness and swelling. Paracetamol seems to take a different route. Most scientists think it works primarily in the brain and the spinal cord, that busy information highway, rather than at the site of the injury itself. It's thought to interfere with those pain signals as they travel through the central nervous system, perhaps by blocking certain chemical messengers or by influencing the parts of the brain that process pain. Section 5. The anti-inflammatory heroes ibuprofen and aspirin's action plan. Now for a different kettle of fish. We're diving into the world of non-steroidal anti-inflammatory drugs, or, NSAIDs for those who like an acronym. This group includes some well-known names like ibuprofen, and of course good old aspirin, the granddaddy of them all. These chaps work in a slightly different way compared to paracetamol. Their main superpower is tackling inflammation. You know, that redness, swelling, and warmth you get with an injury? Remember those prostaglandins we talked about earlier? The chemicals released by damaged cells? Well, they don't just make nerves sensitive to pain, they also cause blood vessels to widen, and they encourage fluid to leak into the surrounding tissues. This leads to swelling and inflammation. It's all part of the body's healing response, but let's face it, it can be rather uncomfortable. Section 6. The opioid enigma, powerful but perilous. Then we come to the opioids. These are the heavy artillery of the painkiller world, names like morphine, codeine, and tramadol. And of course their illicit cousins. They are derived from or chemically similar to opium, which comes from the opium poppy. Humans have known about opium's pain-relieving powers for thousands of years. It's potent stuff, no doubt about it. Opioids work very differently from paracetamol or NSAIDs. They don't primarily target the site of injury or inflammation. Instead, they work directly on the central nervous system, your brain and spinal cord. They bind to specific sites called opioid receptors. These receptors are naturally present in your body. Your body even produces its own natural opioid-like chemicals. Endorphins, for example, the runner's high chemicals. When opioid painkillers bind to these receptors, they do a couple of things. They can block the pain messages traveling up the spinal cord, preventing them from reaching the brain, and they can also change how the brain perceives pain. Section 7. Not so fast. Why pain relief takes its sweet time. You've bashed your shin. Ouch, you pop a painkiller, and then you wait, and wait. Why isn't the relief instant? It's a common frustration, isn't it? You're in pain now, you want relief now, but your body has its own timetable for these things. It's not being deliberately difficult, it's just biology. First, there's the journey we talked about. The pill has to get from your mouth to your stomach, then it needs to dissolve. This can take a little while depending on the pill's coating and what else is in your stomach. Food can sometimes slow things down, or speed things up in some cases, it's all quite variable. Then comes absorption into the bloodstream. This usually happens in the small intestine. The drug molecules have to pass through the intestinal wall. This isn't an instant process. Once in the blood, they need to travel. Section 8, the tricky tightrope, tolerance, risks, and respecting the dose. Painkillers are marvelous, aren't they? When used correctly, they can be a real blessing, turning a day of misery into something manageable. But like many good things, they come with caveats. It's a bit of a tightrope walk sometimes, especially with the stronger ones. One important concept is tolerance. This is particularly relevant for opioids, but can apply to others too. Tolerance means that over time your body gets used to the drug. The same dose that once worked wonders, now doesn't seem to have the same effect. So you might be tempted to take more, to chase that original level of relief. This can be a slippery slope, leading to higher and higher doses, and increasing the risk of side effects, and dependency. Overuse of any painkiller is a bad idea. Too much paracetamol, as we've said, can wreck your liver. Overdo it on NSAIDs like ibuprofen, you could be looking at stomach ulcers, bleeding, or kidney problems, even heart issues in some cases. Section 9, the future of feeling fine, smart relief and parting wisdom. So, what's the big takeaway message? Painkillers are tools, incredibly useful tools, but like any tool, they need to be used wisely, and with respect for their power. Always follow the instructions on the packet, or the advice from your doctor or pharmacist. Don't exceed the stated dose. Seriously, don't. If your pain isn't getting better, or it's getting worse, see a doctor. Here's a surprising fact for you. The color of a pill can affect how well people think it works. Blue pills are often seen as calming, red or yellow ones as stimulating. Even if they contain the exact same active ingredient, the mind is a funny old thing, isn't it? The placebo effect is very real. Our expectations can powerfully influence our experience of relief. What about the future of pain relief? Scientists are always looking for better, safer ways. Imagine tiny nanobots swimming through your bloodstream, delivering pain medication directly to the injured cells, and nowhere else, minimizing side effects, or new drugs that target pain pathways with incredible precision. Gene therapy to correct chronic pain conditions.